We're going to resume and dive into authentication. We're actually going to start with the world's simplest lab, which is really just participating in a brainstorming exercise. If you are watching the video, you have until tonight at 11:59, but I'm going to allocate about 5 minutes now in class. So in the lesson 9 folder, there's a lab 4 link. It says, what comes to mind when you think of web application security? So click this link. It's going to jump you over here to our Monday Miro whiteboard. And I've put a blue sticky note in the middle asking what comes to mind when you think of web application security. All you have to do to complete the lab is click over here on the left for a on a sticky note. And I want you to put your answer, and please include your name because this is for marks. If you don't put your name in your sticky note, I can't mark it. So put on a sticky note and say, my answer here, and put your name. There should be nothing on the board but sticky notes. This is, I don't want you drawing or doodling. Just put a sticky note with your answer and your name. What do you think about when you think of web application security? So I'm going to pause the video now. You've got 5 minutes to add your sticky note. You don't have to submit anything on Blackboard. I just want to see a sticky note with your name on here. Our recording. So I see lots of great comments in your lab. So if you are watching the video, you have until tonight to add a sticky note with your name. So we're going to talk about a number of these issues that I've brought to the table. So just quickly pull up my own slides here. And these are on Blackboard as well, my own notes. So they're here for you. A little bit of a rush job. I didn't include many visuals in here. So here's some of the things that I had in my list. And a number of them have already been mentioned in the lab. So we're talking about sensitive data, and securing access to private information. We've got to consider verification of identity and also permissions. So once we know who our users are, what kind of resources are different users allowed to access? We had a number of comments around passwords, so rules around strong passwords, ways to protect those, having password resets, having two-factor authentication, validating our data for making sure we're getting good inputs in. And a number of you mentioned hacking and preventing our applications against attacks like SQL injection, or for example, cross-site scripting, which is JavaScript-based attacks. We also need to think about maintaining and having access to backups in case something does happen, someone does access or compromise our application, that we have a way to restore our data. A number of you mentioned encryption, and we're going to talk about SSL and SSL encryption, a really important thing that every web developer needs to know about. Spell correctly. And somebody also mentioned things like sessions and cookies, and we're going to talk about both of these and implement them. And so you've done a really good job. I'm seeing a lot of the things, and there's a number of other good considerations that people mentioned in here that we'll try to address for our next couple of classes. So I may have to zoom in a little bit. How does this work? How do we control access to a resource? So might look something like this. So our user asks, show me this web page. So our web server serves the page back. But if this page if we're wanting to restrict access, we're going to check, do we know who this person is, yes or no? If the user has already been authenticated, then we will show them the content on the page they asked for. But what happens if they are not authenticated? Typically, our typical workflow looks something like this. First, we're going to send the user to a login page. They enter their credential, and then we check, right? Is the login they gave us valid, yes or no? If it's not valid, we're typically going to show them an error message, and we're going to take them back to the login page and allow the user to try again. They re-enter their credential. We validate it. We try to verify them against our data store, typically in our database. Once it's correct, we're going to need to store who they are, and we'll talk about why. We're going to use a session for this. And then we can take them back to the original page that they asked for. So this is our kind of basic workflow. I know it's a little hard to see on the slide. There's our basic workflow of securing one web page. We're going to need to talk about sessions and cookies as well. Okay, so remember, HTTP, it's stateless. I think we talked about this back in our very first class. So this means that any variables we have, such as who is the user, those things don't normally persist. They are destroyed from memory on every request. So every time we refresh a page or click a link and go to a new page, we can't easily pass values from one page to another in HTTP. So we need some way, as a user moves around our site, we need a way to keep their identity and then any attached permissions. How do we keep them as they move around and continually make new HTTP requests when each request is basically a standalone stateless request? So we can either use sessions, which is what we're going to do. We can use cookies, and many websites will use a combination. So we're going to talk about sessions and cookies in a minute. We also have considerations around passwords. So we never want to store passwords just as plain text. So they should not be readable. So we're going to talk about hashing and encryption, and we're going to use one of these. And you need to be really clear on the differences between hashing and encryption. They look similar, but there's a very important difference. We should have enforced rules around strong passwords. And then we're not going to be able to implement it in this class, but increasingly the new standard is becoming two-factor authentication. So a username and password is your first factor, and then our second factor might be something like biometric scan, like a thumbprint, iris scan. It could be a text message, an SMS code. That's the most common. It can be answering a security question even after providing a correct username password. And we're a little bit limited in our course. We won't have the ability to send messages from our web server, so we're not going to be able to implement two-factor authentication. But in most real-world applications today, this is becoming standard. And then beyond authentication, we have to look at authorization. Now, here's an important question. It's a great job interview question for a junior developer. What's the difference between authorization and authentication? I'm going to put this one in the chat. This is a question you should be able to answer instantly. It's a common question that an employer might ask you. So authentication and authorization, they're related, but they're not the same thing. What's the difference? Happily wait for an answer on this one. Okay, authorization gives admin commands. In a way, Belinda. Okay, Paramveer, authorization is about ownership. Okay, potentially ownership. Authentication is validation. Right, okay, so authentication is step one. Authentication validates who the user is, Sarah says, and authorization is what the user is allowed to do. Absolutely, that's a great description. Thank you, Sarah. So authentication is our first line of defense and security. It's identifying who is this user. Authorization is that second level. Once we've identified the user, what is this user allowed to do? So it's around access to resources. Okay, so if we think about Blackboard, yes, authentication is the process of identifying the user. So authentication happens. So here's where authentication happens. Okay? Where I'm being prompted to identify myself. So we all have to do this every time we come to Blackboard. Once I identify myself, we can see authorization. If you look at my version of Blackboard and compare it, if you're in the lesson 9 folder, so we already have performed authentication to get here, but we can see there are also authorization checks here. How can you tell visually that there are a whole number of authorization checks on this page? Even if you and I are looking at the same page, we see different things. What can you see here that's different? Right, so I have this edit mode. So there's a little if statement, there's an authorization check here that checks what role are each of us in, even when we're both looking at this same page. So it's checking if you are in a student role, this element is hidden. If you're in a faculty role, this element is visible. Yep, I get these purple bars that allow me to reorder the items in the folder. Yep, I've got these links that I can create new items. Hey, I'm going to create a test for you guys. What else do you see that indicates there are authorization checks going on all over this page? Yeah, I've got drop downs, right? So I can modify the navigation here. You don't have those. I can also see items that are no longer available to you. And I have drop downs, so again, I can interact with these items. Like make them available or unavailable, change the due date, move them, change them, delete them. Yeah, I get the extra menu under course management. So all of these things are based on authorization. Blackboard has identified us, but it's checking for all of these visual elements. There's all kinds of authorization checks that depending on what role we have been assigned to, we can see and do different things. Right, I mean, basically, I have the access to control the content and you have access to read the content only. That's how this works. So we've got the ability to modify versus the ability to read only. We may have access control on individual pages, and then what we're largely seeing was items within a page. So all kinds of things are shown or hidden depending on our roles. A number of you also mentioned encryption, and we are going to talk about SSL a bit more probably next week, and we'll explain why it's so important. But in general, all the messages sent via HTTP are in plain text. So if I enter a username and password here, it gets sent from my browser to my ISP, all the way off to the server wherever Blackboard is hosted. And all of that traffic, including my email and password, are sent in plain text. So what SSL does is it ensures it encrypts the traffic instead. So we'll talk a bit more about SSL, how you would install and configure an SSL certificate, and why every modern website today needs an SSL certificate. Even if it's just a read-only static HTML, JavaScript, CSS site with no database, no credentials, no sensitive information, even those websites need SSL. So we'll talk a bit more about that probably next week. Okay, we're going to come back to sessions versus cookies. So a couple things that we want to do now is we want to start to set up our PHP Flicks so that first of all, we want these links to load actual pages. And then we also will need a place to store users in our database so that we can start to get our register and login pages working. Those won't work if there's no user store in the database. So first, we're going to create a users table. So I'm going to connect to my database in MySQL Workbench, and we're going to run this little script here to create a user table. So you can connect to your database either through MySQL Workbench or phpMyAdmin, however you get there. So I'm going to connect to my AWS database. I'll just click it over here on the left, double click it. I've already got a users table, but I'll delete it. I'll recreate it. So then all I want you to do in the lesson 9 folder, there's this item that's called user table script. Just highlight and copy that simple command. And then I'm just going to paste it in and execute it. So this is going to build a table called users. The table will have 3 columns. A user ID, so that's going to be auto-generated, a primary key. And then we will have a username and a password. So all I'm going to do is paste that script in and execute it. And it will build the table. Now you'll notice the password field is really long. How come? We're not really going to ask someone to enter a password that's 255 characters long. But I did this for a reason. Why would I make the password field so big? Okay, yeah, because we're going to want to do something with encrypting or hashing the passwords. That's right. Now, what's the difference? Encrypting and hashing, they look similar. So for example, let's put in the chat. So if I put in, password 1234, we want to convert this so it looks something like this, right? We want to store a value in the database that looks something like this. So both hashing and encrypting would convert some plain text value into something that looks like this. But there's an important difference. What's the difference between hashing and encryption? Again, this is another, well, I'm just typing it in the chat and I'm sharing my screen. Can you see the chat? Oh, okay. Sorry. I hit enter. So we're converting something like password 1234. If we hash it or encrypt the value, it'll give us what will look fairly random. So we could use hashing or we could use encryption. But what's the difference? We typically want to use one and not the other for passwords. Are passwords generally hashed or are they encrypted, and why? They look the same, but there's a really fundamental and important difference between the two. Okay, Paramveer says hashed. Well, again, they're similar, Belinda. So it's taking plain text and converting it into a long string of what appears to be random letters and numbers. Hashing is a form of encryption, in a way. But what's the difference between the two? If I was hiring a junior web, okay, Masa, that's right. Okay. One of these processes is a one-way process, meaning we can convert this to this, but we can never go back from this to this. The other process is two-way. So we can go from plain text to random string, and then also back from random string back to plain text. So which one, hashing and encryption, which is one way and which is two way? Right, Paramveer. Hashing is one way. So we can convert password 1234 to this, but we can never, you can't unhash or go from this back to this. Encryption is a two-way process. So we can convert plain text to random string and then random string back to two-way. That's encryption. So the standard is to hash a password. Think about what happens on most websites if you forget your password. Do websites have some way for you to be able to retrieve or see your old password if you can't remember it? Do most websites allow that? Right, Masa, they don't. Right, or most websites do not. Yeah, but what happens in the email? Do they email your original password to you? That's right. They identify you some other way and they force you to reset it. And that's because the passwords are hashed. They have no way, even if they wanted to show you, when we hash a password, you cannot convert this back into this. Can't be done. So hashing is more secure than encryption, and we are going to hash the passwords. So even if we enter a short password, like this one, which is 12 characters, we want to allow 255 because hashing is going to give us a much longer password. Now, it won't be as long as 255, but the hashing algorithm we're going to use in PHP, it could be that long. So we should make space for a long password. Paramveer, in answer to your question about the assignment, no. If you choose assignment B, you watch the video and you have to, if you don't understand after watching the video, if you don't understand how to do a content management system, then you shouldn't do that option. You should do option A. Okay, I'm not teaching you how to do the assignment. You have to adapt what we've learned in class to that particular problem in order to get the 100% option. Okay, so that's why that assignment is worth more, because you'll have to do some of that work. If the content management system after watching the video still doesn't make any sense to you, then I would suggest you do option A instead. The method is just create, read, update, and delete. So yes, we've already learned that. You have to adapt the create, read, update, and delete to that use case. There's no special methods for creating virtual pages. Yeah, that wouldn't be very secure. Okay, so we've got a users table. So the next things that we need now are we need register and login pages. To save us time, I've just posted the HTML we need for this onto Blackboard. So here's what we're going to do. So we've grabbed our user table script, we've pasted it and run it in our AWS database, so we now have a users table. I'm going to go back to Blackboard. To save time, I created these forms. So I'm going to copy all the HTML here. Oh, there shouldn't be a footer. We didn't create a footer, so let me just edit this. I'll take it. Put that out. So I'm going to copy all of the HTML here. I'll go back to Visual Studio Code. Close up some stuff. So I'm going to click into my root folder. I don't want to be in the includes. I'm going to make a new file called register.php. And then I'm just going to paste in all of the HTML from Blackboard. Yes, Paramveer, that's correct. No, encryption would be done if you wanted to encrypt data, you would do it with PHP. We don't encrypt it in the SQL itself. Okay, so now here's my register page. So if we already created a register link, so now when I click it, save. Okay, one small error. Okay, I'm sorry, Paramveer, if you've got other questions about the assignment, maybe you could send those to me by email. We do have to move on with today's lesson, so unfortunately, I'm happy to answer your questions, but please send them to me via email or book an office hours appointment. I'd be more than happy to help, but I don't have any more time to address today's lesson. Okay, so our path to header is not quite right. And our CSS is broken. So in our include, I've got to change the path and add in. No, Paramveer, you can't set up the security in the database. No, that has to be done at the coding in the application level, not in the database itself. So I'll change that path to includes. So now here we've got our register page. If I click login, I'm still going to get 404. Ah, right. Thank you, Belinda. Sorry, I will fix that up. Nice catch. I appreciate that. So I'll repost this. I'll just repost it to Blackboard. I had to change the path to the header because our header is in the includes folder. Okay, so 3 changes. Add includes before include slash, and then we just added the closing body and closing HTML. Oh, because I did this a while ago. Sorry, Daniel. It should use require. Thank you. Should be require. Thank you, Daniel. So the reason is I posted this code a while ago. So I should probably use require. Well, that's a good catch. We may as well be consistent with it. I will update the login as well. So bear with me. I'll make those updates here. That's right. Much easier when it's a social exercise. So I'll make those changes to login. Okay, now we can go and grab the code for login. Just refresh your page one more time. And now I'm going to make a new file called login.php. So now our register and login links should both be working. I think there'll be a few CSS changes we're going to make. Register works, login now works too. There are a couple of CSS items I'm going to clean up on here as well. You'll notice the form is really jammed together and our buttons are blue. I want the form to look like these. So I want my button to be gray and I want a little bit of spacing. So I can just take out a couple things, make a couple changes in register and login. So first of all, in my field sets, I'm going to take out these class of form group. That's a bootstrap class. We don't need it. Take it out. And I don't want my buttons to be blue. I want them to be gray. So I'm going to change the class to from BTN primary to BTN secondary. And I've removed the classes on my field set tags. This should give us the opening body tag is in the header. Because it includes our nav. And remember, these get spliced together at runtime. So I've removed the form group classes. I've changed my button from primary to secondary. So it should toggle from blue to gray. Interesting. Oh, sorry, I needed a class. The class I used in movie details was M1. That gave it our margin. So I'm going to put that on my two field sets. A margin of 1, so that the input boxes aren't nested right together. There's a small margin between those field sets. So I had form group. I'll change it to M1. There. So now I just get a small margin. I'll make those same changes on the register page. My field sets are jammed together and my button is blue. So on the register page, I've got 3 field set tags with the class of form group. I'm just going to change those to M-1. I will post all this to GitHub. Yeah, don't worry about it too much. And again, I'll change my button from primary to secondary. So it should be gray. I've also added a regular expression on the user registration. So we're enforcing at least medium strength password. It must have at least 1 lowercase, 1 uppercase character, and it must be 1 digit, and it must be at least 8 characters long. Actually, was reading on the weekend that all passwords should now be a minimum of 12 characters, but I'm going to leave it at 8 now. Okay, so my button, probably want to offset it 2, not 3. Okay, so the pattern. So this means the D represents a digit. There must be at least 1 number. There must also be at least 1 lowercase and 1 uppercase. And this is the minimum number of characters. There is no maximum, but this is the minimum. This is evaluating. This is just evaluating the characters in the string. So this represents the password entered. And then this part of the equal sign, this is the requirement. There is at least 1 digit. Okay, so you can read more about regular expressions if you want more information around their syntax. Well, this means somewhere, somewhere inside the password. It doesn't matter. We don't care what character the digit is at, but at some position there must be a digit. And the slash D means digit. So at least one of the characters somewhere in the string must be a digit. Okay, I'm not going to go. Sorry, I don't want to spend too much time. We could spend forever on regular expressions, and 8 is the minimum. Yes. So I will let you do some more exploration on your own if you want to dive into the. I don't want to get too bogged down in the details of regular expressions because they're very complicated, and we'll spend the rest of class dissecting. So you're asking good questions, but we can talk about that outside of class, or you're free to do. Okay, so before we can use login, we obviously have to be able to create a page where we can register users. So our form posts to a page called Save Registration. So we're going to need to build this page. So I'm going to make a new file called Save Registration, PHP, and we'll include our header. This is called save-registration. It's called a regular expression. Okay? They could almost be a course all on their own. So I'm using it to enforce a strong password, but I don't want to get into spend too much time dissecting the syntactical details. So you can read about them. And we require so we will capture form inputs, validate inputs, connect to the database. We will check for duplicate user. So we don't want to let a user sign up with an email address that we already have in the database. So we've got a fair bit to do on this page. So most of this stuff we've done many times before when we're saving data from form, but a few things are a little different. We're going to have to do a check before we save. We're also going to have to hash our answer. So we've got 3 inputs. We'll have username, which we will get, and we're going to get all these from our post array. So we're going to grab the username. We're going to grab the password. And I'm just going to check. I'm glad that helps. Our other field was called confirm. So we had username, password, and confirm. So this will allow us to read the values the user types into our registration form. We want to validate that none of these fields are empty, and also that password and confirm password are the same. So we'll also create a variable here called OK, and we'll set it to true. So if our username is empty, we'll print an error in red. Actually, print it in yellow maybe. And we'll set our OK flag. We'll toggle it from true to false. We're going to do the same thing for password. So I'll just copy and paste. If they don't enter a password, we're going to say it's required. We don't need to check the confirm for empty. We just need to check whether our confirm variable and our password variable are equal. Say if password does not equal confirm, so those are our three validation checks. Make sure they give us a username, make sure they give us a password, and make sure the confirm password and the password are the same values. And then everything else on this page only happens if we have no validation errors and our OK flag is still set to true. So we could try this out. I'll put in a username and a password, but then I'll put in a different value for the confirm field. And we should get a yellow message saying passwords do not match. I'll go try it out. So I'll put in an email. So I've got two different passwords. So I get this passwords do not match. That format isn't working very well for showing the error. I'm going to change this to different class. I'll use alert space alert warning. That should make that message easier to read. There. Gives it that yellow background. If I put in two passwords that are the same, I should just get a blank screen right now. There is no error. Well, Belinda, it's not really necessary because if it doesn't match, if we put in a password and confirm is empty, then this condition is still going to be true, that the passwords don't match. So you can, but it isn't really necessary. So then everything else in here, I'm going to indent because all of this stuff only happens if OK, if our flag is still set to true. Okay, so I will now say if $OK and open a set of curly braces, and all of this code is going to get moved inside. We're not going to connect to the database or do any of this if there are validation errors. It is 9:50, so we have some more work to do on this. It's going to take a little bit. So what I'm going to do is I will upload everything up to GitHub right now. Okay. And we're going to take a break here. We'll come back in 10 minutes. We'll finish our save registration page, and then that should allow us to then create a new user with a hash password, and then we can go and work on our login and see how this works. Okay, so I'm going to upload to GitHub, and we will take a 10-minute break.